Okay, welcome back. Where we left off last time, we just created a basic terrain. You see we've got a bit of water going on, a few mountains, and I think I'm quite pleased with this to start with. And our target for today was to create a bit of a day-night cycle so that this terrain looks a bit better. But first of all, I'm just going to go into the project here and I'm going to right-click the terrain data that we've generated here. Oh no, not right click. I want to center click on that. I want to rename it just to sample terrain, just so we know what everything is. This actually contains all the information about what we just created. So this is to do with the textures. So all the bright green is where the grass is, and all the red is where the mud is. Okay, so we'll close that up. If you haven't already got a scripts folder, I just recommend you go create folder and name it scripts to keep yourself organized. And I'm just going to create a new C# script in here, and I'm going to call it day and night cycle. Okay, it's worth mentioning here that for this for these videos, I'm actually going to be using Visual Studio to do the programming. If you have Visual Studio installed, to use it with Unity, you need to go to Edit and then Preferences. And then if you go down to the External Tools section, you can go to Browse. It won't automatically be in there. Click Browse and then navigate to where your Visual Studio is installed. I'm not sure where mine is. You can look it up. You've got a few iterations here, and then find the C# editor. I don't actually know where mine is specifically, but if you can't find it, I recommend just looking online or go to your Visual Studio link and properties, and then this actually tells you the file path where Visual Studio is. Obviously you can use any other editor you like. However, in my experience, MonoDevelop recently has become really buggy. I got repeated crashes and then compiler errors coming back into Unity. So I found it's actually more hassle than it's worth to use MonoDevelop, and Visual Studio is really quite a nice editor. I'm actually going to double click this. It takes slightly longer to start Visual Studio than MonoDevelop, but I would say once you start it up, obviously you're rolling. So okay, here we go. Visual Studio is just booting up now. Alright, there we go. So we've got our script. I'm just going to make a bit more space for coding. I'm going to drag this across because we don't strictly need this section for now. Okay, so this is what we've got so far. If you're not confident with C# scripting, I'm not going to go over the very basics, though you should be able to follow along quite easily with what we're doing for now. So first of all, to do a day-night cycle, I'm going to have some kind of notion of time. So I'm going to create a float time. Actually, I am going to make that a public float, and I'm going to set that equal to 0. And that's just going to keep track of, let's call it, say, time in seconds. Also some other information we might want is public float the day length, which I'm just going to set to 60 seconds. This is just how long it takes for a day to pass before you go into night, and then night will take the same length of time to come back to day. And the other thing I want is public transform, and then I call that directional light, and that's just going to be a reference to the light that creates the sun, basically, that will make rotate. Okay, so first of all, I think what we're going to do is set a tag for this directional light. So I'm going to add a new tag. I'm just going to call this sun, just in case we can't find the directional light. So I'm going to tag that as sun, so this script won't fail if the directional light isn't attached. So we'll say if directional light double equals null. So what that's basically saying, if we haven't been given a directional light, we'll say directional light equals game object dot find game object with tag sun. So that's just going to go into the scene and find the one with the sun. But then the directional light is a transform object, so we need to get that object's transform. Okay, so that should give us the directional light. And then some notion of time updating. So for every frame, what we actually want to do is add sum to time. So time plus equals, that's adding a bit, and I'm going to do time dot delta time. So what this does is it basically keeps track of time as if it's real time for a human. So time dot delta time is the time it took the last frame to render, and because update is called every frame, this will just keep track of basically how long the game's been running. There is another function you can use called time.time, and that is the time in seconds since the game has started, which would give us a similar idea, but that involves a bit more initialization because if the user, for example, spends some time in a main menu before coming to the game, time.time is going to be, say, it's going to be how long they've spent in the main menu. Whereas in this, we want time to initialize at 0. Okay. Let's think about this directional light, because we want to set the rotation value of the directional light. And what we want to set it to is basically how far through a day we are. So if we are 60 seconds in, we want to make sure we're 180 degrees. So I'm just going to create a float of degrees just while we're thinking about the maths. What I'm going to do is say time divided by day length, so that gets how long we're through a day. I'm going to times that by 180 degrees. So what that's going to do is it's going to, if time and day length are both 60, then the degrees are going to be 180, because time divided by day length would be 1. Just some basic maths there. And as time decreases, the angle gets smaller and smaller. So when time is 0, the angle is going to be 0. Also, if time is double what day length is, so we've gone through day and night, then we'll be on 360 degrees, which will reset it back to 0. Actually, I don't need this variable. I'm just going to keep that math there. We are going to get a underline there just because it's not correct. If we go to directional light dot, we've got rotate and rotation. If we have a look at rotation, we can actually have a look at the set Euler angles. So what Euler angles are is the angles in degrees of how the light is rotated. And this actually takes a vector 3, so because there are 3 dimensions you can rotate in, x, y, and z. If we take a look, we'll just see which dimension we want to rotate in. So at the moment our light is coming from over here, and we actually get the sun. We have a look at, I think it's probably, yeah, the x value like that. You see the sky box is dynamically changing there, which is really nice. That's also a Unity 5 feature. Yeah, so when rotation in x is 0, it's the start of the day. When rotation x is 90, it's midday, which is correct. So we actually want, we want to set the rotation x. So we want to set that to this maths function. And the other two need to be just what the rotation already was. So we want directional light dot rotation Euler angles dot y, and that gets the angle in degrees for y. And I'll just copy and paste that and change that to z. So we should lose that. Oh, I think I forgot the semicolon at the end. No. What's wrong with that function then? Set Euler angles is is actually not correct. So it says here to use Euler. We'll give that a go. I'm not actually sure on the Euler function. See what it does. New vector 3, so what's the error we've got now? Qualify it with a type name. Okay. So we want to see rotation equals quaternion dot Euler. That's my mistake there. I told you I'm not actually planning these through. Just if I make mistakes, then I say that's just how it goes. So this actually generates the correct angles to give to rotation. And the last thing we want to do is set time equal to time mod 360. Oh, sorry, not 360, we want day length times 2. And what this will do is it will loop time back to 0 at the end of the day. We'll probably want to modify that later when we add some different days and months, some notion of years as well. But for now I think this will work. Jump back into Unity and see if we've got any errors here. Something you do get with Visual Studio is this line endings thing, but at the moment I think we'll be okay on that. I think Unity uses this Mac line endings, and Visual Studio uses Windows. If someone's got a fix for that, it would be interesting to know. Okay, so it looks like we haven't got any real errors here. And I'm just going to create a new empty game object and just call it time manager and drag day-night cycle onto that. I'm just going to test to see if it can find the directional light first. So if I click play, hopefully this will work. There you go, so we've actually found the directional light. If I go back into the scene view, you can see the directional light is rotating correctly. Sun is rising in the sky. Usually you wouldn't really see that, but that's just a feature of this procedural skybox. As the sun rises, it gets brighter and brighter. And you'll see later on, we're now at the peak sun. And now the it's broken. Why is it broken? That's an odd one. Because the X value is definitely decreasing there. Okay, let's have a think about this then. So if we look at quaternion.Euler, in fact I might just take a research on this and I'll come back to you in the next episode and we'll see if we can fix it. Anyway, thank you very much for watching, and I'll see you in the next video.